Okay, good afternoon, students. Okay, today I'll be start the pulse and digital circuits, unit 1. So linear wave shaping. Directly I'm going to the basic one. So linear wave shaping, main important one is sinusoidal input applying to the linear circuit. So linear circuit is nothing but made up of linear elements. So linear elements are RLC. So why you call as these three are will be linear elements? Because it will follows the V voltage and current relationship is proportional. V is proportional to I. We know that Ohm's law V equal to IR. So here will be at constant temperature. That is the Ohm's law V is equal to IR. That means linearity property has to satisfied. That means input waveform and output waveform will be a linear one. There's some proportionality constant will be there. Here important one is sinusoidal input applying to the linear network, output waveform also sinusoidal waveform. That means wave shape will be same, no change. Only change is amplitude and phase. And similarly, non-sinusoidal signals. So non-sinusoidal signal means what are the non-sinusoidal signals? Step input, pulse input, square wave input, ramp and exponential. These waveforms applying to the linear network, output waveform shape will be changes. So this process is nothing but linear wave shaping. Now, already I have shown this diagram. Input and output waveform of the sinusoidal. I have taken one example in the diagram. Bottom side sine waveform and cos waveforms. How it will be? Phase angle 90 degrees will be changes. So one is the input, second one is the output. Because sine integration, the reading is a cos. Similarly, sine differentiation, cos waveform. That means either integration or differentiation, you are writing the sine waveform, you are writing cos. Either it will be plus sign or minus sign. That is the magnitude. But waveform shape will be changing. Same. Now come to the what is the linear elements. Already I told that VI characteristics will be satisfied or superposition theorem principle is valid, then you call as linear elements. Superposition principle means there are the two principles. One is the homogeneity property, and homogeneity means scaling. Y equal to mx, m is the scaling factor, x is input and y is the output. A2 property, already I told that. So two signals you are applying at a time, then what is the response? Individual one signal applying, what is the response? Plus another signal you are applying, then what is the response? Individual signals applying, what is the response will comes? That equal to sum of the responses. మీకు ఇంతకుముందు చెప్పాను ఆల్రెడీ. ఇద్దరు కలిసి ఒక వర్క్ చేస్తే 1000 రూపీస్ సంపాదించారు. అదే ఇండివిజువల్ వర్క్ చేస్తే ఒకళ్ళు 400, ఒకళ్ళు 600. టోటల్ అమౌంట్ విల్ బి సేమ్. That is the A2 property. These two, A2 property and homogeneity property, is nothing but superposition. So this superposition theorem is valid for discrete elements, that is RLC. Now come to the unit 1 definition of the linear wave shaping. This is a very important definition. The process whereby the form of a non-sinusoidal signal. So non-sinusoidal signals means 5 signals except sinusoidal, remaining other one. What is the remaining other one? Step signal, pulse signal, square waveform, ramp, exponentials. So these non-sinusoidal signals is altered. That means shape of the waveform will be changes by transmission through a linear network. So linear network gunda మనం నాన్ సైనూసోయిడల్ సిగ్నల్ ట్రాన్స్మిట్ చేస్తే అవుట్పుట్ వేవ్ ఫార్మ్ షేప్ చేంజ్ అయ్యింది. దిస్ ప్రాసెస్ ఈజ్ కాల్డ్ యాజ్ లీనియర్ వేవ్ షేపింగ్. సో లీనియర్ నెట్వర్క్ మీన్స్ దట్ విల్ బి మేడ్ అప్ ఆఫ్ బై RLC కాంపోనెంట్స్. సో లీనియర్ ఎలిమెంట్స్ ఆల్రెడీ ఐ టోల్డ్ దట్ RLC, బికాస్ ఎందుకు RLCనే మనం లీనియర్ ఎలిమెంట్స్ తీసుకున్నాం? కరెంట్ పాసింగ్ త్రూ ది ఎలిమెంట్స్ ఈజ్ ప్రపోర్షనల్ టు అప్లైడ్ వోల్టేజ్. So your voltage value increases. Let us example RS series circuit. You are applying input voltage increases. corresponding current also will be increases. Hello. ನಾನು తర్వాత చేస్తాను క్లాస్లో.
సాయిబాబు గారికి 30 లక్షలు ఇవ్వాలి.
Hello, sir. Hello, Saide sir.
మ్యూట్ అయ్యారు సార్.
ఓకే ఓకే మా ఇప్పుడు చూడండి. ఓకే
సార్ అది మినిమైజ్ చేయండి.
ఓకే ఓకే మేడం ఇప్పుడు వినపడుతుంది చూడండి, వాయిస్ వినపడుతుంది, స్లైడ్ కనపడుతుంది మేడం.
స్లైడ్ కనిపిస్తుంది, వాయిస్ వినిపిస్తుంది. కంటిన్యూ చేయండి సార్.
ఓకే ఓకే. సో హియర్ విల్ బి లీనియర్ వేవ్ షేప్ సర్క్యూట్. Here what is the linear circuit components? Passive elements. Passive elements means RLC. But these RLC, which combination will be considered depending on the application? Suppose I want to be integrator. So integrator means this RLC circuit, which component I have to use it? Less cost and efficient output I want to produce. Best integrator. So for this purpose, we are using RC circuit as an integrator or differentiator purpose with less cost and size also very less compared to RL circuit. That meaning is either will be RC circuit, we can utilize low pass or high pass. Similarly, RL circuit also, that means the resistor and capacitor combination can be using as a low pass or high pass, or otherwise low pass means integrator, high pass means differentiator. Similarly, RL's combination also can be utilizing either integrator or differentiator. But why you are using RC circuit in your second year subjects also or EDC lab anywhere? So generally filters you are considering means resistant capacitor. So why you are considering only resistant capacitor combination as a filter? Because capacitor has small size compared to inductor. So inductors will be some stray resistance capacitance will also be produced. So pure inductor is not available and size also very high, cost also very high. So that's why RL circuits will be less utilization compared to RC circuits. That's why RC circuit resistor and capacitor combination filters many times you are using in practical applications. Similarly, RLC series and parallel circuits where you are using, that will comes in the later. This is a linear circuits. What are the components inbuilt? అంటే లీనియర్ సర్క్యూట్లో ఏం ఎలిమెంట్స్ యూజ్ చేసుకొని మనం సర్క్యూట్ని మ్యానుఫ్యాక్చర్ చేస్తాం. ఆ సర్క్యూట్లో ఏ కాంపోనెంట్స్ ఉంటే హౌ టు బి ఆపరేటింగ్ దట్ సర్క్యూట్. సో ఆర్సి రెసిస్టర్ అండ్ కెపాసిటర్ కాంబినేషన్ ఉంటే either will be integrator or differentiator. Similarly, RL combination also can act as an integrator or differentiator. These two, not RLC circuit. Either RC combination or RL combination can be act as a integrator or differentiator. Now come to the non-sinusoidal signals. So what are the non-sinusoidal signals? Already I told that except sinusoidal, remaining all other are non-sinusoidal signals. Non-sinusoidal signals means in our subject pulse and DC circuits we are utilizing 5 signals. So what are the 5? Let us see. First one, step input. So step input and graphical representation also will be shown here. So this graphical representation, what you have seen, x-axis will be time value and y-axis will be taken as voltage value. That means magnitude of the input signal amplitude. Now at t less than 0, that means negative values of time, negative x-axis. So signal strength value, that means signal amplitude voltage value is 0. Whenever t is greater than 0, small t, that means x-axis positive values of time. So voltage magnitude equal to V volts, constant voltage for positive values t greater than 0. All positive values of time, constant amplitude V volts. This is a step voltage signal. But what is the difference between unit step signal and step signal? This will come in the signals and systems also. So unit step signal means y-axis amplitude equal to 1, voltage magnitude equal to 1. X-axis will be time, that will be same, similar one here also. Only change for step signal and unit step signal is amplitude is variable. Unit step means y-axis amplitude equal to 1. Step signal means some voltage value, constant value, V volts. And pulse input. So pulse input means only specified time interval having some constant magnitude. Now see the diagram. At t equal to 0 to small t equal to tp. Let us example tp equal to 1 millisecond. That means 0 to 1 millisecond constant amplitude V volts. Within the 0 to 1 millisecond constant amplitude V volts. That V equal to I am taken as 5 volts. So 0 to 1 millisecond 5 volts amplitude constant value. Remaining other intervals of time, other means t less than 0 and t greater than tp. So magnitude of the pulse value is voltage magnitude equal to 0. That is the indication. Equation also as shown in the diagram. Similarly, square waveform. So square waveform or sinusoidal waveform, these are the periodic waveforms. So what is meant by period? Fundamental period or period. So period is nothing but any waveform after certain interval of time, again same waveform will repeat. So here simple example, sinusoidal signal, everybody knows. That's why I'm taking sinusoidal signal example. But the actual topic is non-sinusoidal signal. But understanding purpose, I'm taking sinusoidal signal. So we know that sinusoidal signal 0 to pi is the positive peak. Similarly, negative peak is starting from pi to 2 pi. Now here 0 to pi, positive peak duration is pi. Similarly, negative peak duration from pi to 2 pi also duration is pi. That means positive peak time period and negative peak time period will be same. The type of waveforms nothing but symmetrical waveforms. Symmetrical. After 2 pi interval of the sinusoidal signal, again same waveform will be repeat, positive peak and negative peak. Similarly here also for a square waveform, 0 to small 0 to capital T1 interval. That means positive pulse. So 0 to capital T1 interval having constant level, and capital T1 to T1 plus T2 interval another voltage level, that is a negative voltage level. Suppose positive interval plus 5 volts. In the negative interval T1 capital T1 to T1 plus capital T2 interval minus 5 volts. That means peak to peak value of square waveform is plus 5 to minus 5. Peak to peak value is nothing but 10 volts. Here will be after T1 plus T2 interval, again same waveform will be repeated. Same waveform means at t equal to 0, whatever the waveform will be there, same waveform will be repeated after capital T. So capital T is nothing but T1 plus T2. That means positive pulse duration plus negative pulse duration. And T1 and T2 are equal and equal to T by 2, capital T by 2. Then his waveform is called symmetrical square waveform. So difference between symmetrical and asymmetrical is only so positive pulse intervals and negative pulse duration values will be same or different. You have to see it. That is the only change. And next waveform is ramp input. So ramp waveform means here I am taking as positive going ramp. So positive going ramp means waveform starting from t equal to 0 to some positive value of time. So ramp waveform means x-axis time value increases, y-axis amplitude also will be increases. So this is a y equal to mx equation, already you have studied in the mathematics linear equation. Similarly here y means here vi of t, and mx, m means here slope alpha I am considering here, and t is nothing but x-axis I am considering t. Previous one y equal to mx equation, x-axis and y-axis will be considering. Here will be x-axis time will be considered, y-axis will be voltage. So that's why v is equal to alpha into t. This is a ramp equation for the positive going ramp. and alpha is nothing but slope of the waveform. For positive value certain, that's why small t greater than 0 is indicated. Similarly, exponential waveform. So exponential waveform is nothing but non-linear waveform. That means ramp waveform and exponential both will be different. So ramp waveform is linear, exponential is non-linear. That means, let us example 0 to 1 millisecond, one waveform increases by 2 volts. 1 millisecond to 3 milliseconds, amplitude will increase 10 volts. Next 3 milliseconds to 4 milliseconds, 15 volts or 30 volts. That means is not a uniform. Particular time is uniform will be considered, but y-axis voltage variation will be non-uniform. That is a non-linear waveform or exponential waveform. This exponential waveform where will be occurs means generally capacitor will be charging and discharging exponentially. These are the non-sinusoidal signals. Now come to the actual syllabus of the first unit. So low pass RC circuit. Low pass RC circuit. So this low pass circuit meaning is nothing but it will transmit only low frequency signals and attenuates or stops the high frequency signals. The meaning is, suppose I am considering low pass filter is nothing but this resistor capacitor combination is called as low pass circuit. Input side I am applying different input signals. Let us example function generator, we have taken example as a signal source. Now function generator we available different frequency signals, either will be 1 kilohertz or 10 kilohertz or 20 kilohertz or 30 or 1 mega also. Likewise different frequencies variable. Likewise in the atmosphere also different signals is available, different frequencies. Simple example, our voice signal, I have taken example or speech signal. So human voice will be around will be 2 kilohertz to 3.5 kilohertz. Audio frequency range is 20 hertz to 20 kilohertz. Likewise different frequencies available. Similarly FM radio, another FM radio and FM radio 98.3 or 93.5 megahertz. All frequencies are available in the atmosphere, that means air. So these all signals will be coming to this RC circuit, but this RC circuit will act as a low pass. That means it will be allowing only low frequency signals. Let us example this low pass filter passing only 0 to 10 kilohertz. That meaning is it will be transmitting only 0 to 10 kilohertz input signals without attenuation. So whatever the input will be there, same input is transferred to the output within the 0 to 10 kilohertz. So 0 నుంచి 10 kilohertz వరకు ఏదైతే ఇన్పుట్ సిగ్నల్స్ ఉన్నాయో sinusoidal waveform or square wave any waveform, whatever magnitudes of the input side, same magnitude, almost same magnitude is transferred to the output. After 10 kilohertz above input signals, suppose input signal is 20 kilohertz signal, I am applying this RC circuit, then output will be 0. Similarly 50 kilohertz, I am 100 kilohertz. Likewise different frequency signals I am applying to the circuit, output is 0 you are getting. That meaning is high frequency signals is not transmitted. How we can say that this circuit is low pass RC circuit? అంటే ఈ సర్క్యూట్ ని లో పాస్ ఆర్ సర్క్యూట్ అని ఎలా చెప్తాం? What are the reasons you are using? Here will be I am considering 3 points in the figure diagram. You have to see bottom one. So first I am considering at 0 frequency. At 0 frequency means which signal is available, either AC or DC. So generally DC signal having 0 frequency. 0 frequency means how to getting 0 frequency? DC signal means constant line. So constant line means x-axis time value varying, but amplitude will be constant. So time period is infinity. So once will be time period is infinity, frequency is 0. So that is a DC signals or 0 frequency signal or constant signal. Everything will be same. Suppose I am applying 0 frequency or DC signal or constant signal to the low pass R circuit. This circuit, RC circuit. What will happen? Here will be capacitor reactance formula. We know that capacitor reactance formula is 1 by j omega c. So here I am considering magnitude, j is I am eliminating, x equal to 1 by omega C. That is the reactance of the capacitor. Now what is the omega? So omega means angular frequency. That value equal to, in terms of natural frequency f, is 2 pi f. So omega is equal to 2 pi f. So difference between angular frequency and frequency. So angular frequency is nothing but units is radians. Omega units is radians. Frequency units is hertz. And C means here capacitor value, either 1 microfarad or 10 microfarad. Likewise will be capacitor, already are using in the EDC lab. Likewise will be capacitor value. Now capacitor reactance is 1 by 2 pi f into C. In place of f I am substituting at 0 frequency, because you are applying input is 0 signal frequency or DC signal or constant signal. So now in place of f I am putting 0 means 1 by 0. X equal to 1 by 0 means infinity. So infinity means capacitor reactance is infinity, means capacitor act as a open circuit or short circuit. This will be open circuit. So once will be capacitor is open circuit means only components is input, resistor and output. Whatever the input will be there, same input is transferred through resistor to the output. Here will be some doubt will comes. Sir, resistor is there, some voltage drop will be there. But here will be resistor voltage drop is almost will be very small value. Let us example, input equal to 5 volts. So resistor drop equal to 0.1 volt. Output you are reading 4.9 volts. So 4.9 volts almost equal to 5 volts. That means drop across the resistor is very small value will be considered. So first one at 0 frequency, input and output almost will be same. So once will be input and output will be same, what is the voltage gain value? So voltage gain means output voltage by input voltage, V0 by Vi. So that value equal to UNIT-1 whenever frequency 0. So next second point, as the frequency increases, so that means capacitor input signal frequency I am increasing, capacitor reactance, what will happen? Input side I am increasing frequency, previously 0. Now I am putting frequency f equal to 1 kilohertz. Let us example 1 kilohertz input signal, sinusoidal signal or square anyone, some signal applying to this RC circuit. Then what is the capacitor reactance formula? Capacitor reactance formula is x equal to 1 by omega C, that equal to 1 by 2 pi f into C. In place of f I am substituting 1 kilohertz, 1 into 10 power 3. That is example capacitor value 1 microfarad. So 1 microfarad means 1 into 10 power minus 6. Micro means 10 power minus 6. So multiplied and simplified. Almost suppose 2 pi eliminate chesam anukondi, 1 by fc. F equal to 1 kilohertz means 10 power 3. Capacitor value is 10 power minus 6. So 1 by 10 power 3 into 10 power minus 6. So in the denominator 10 power minus 3. Coming to the numerator means 10 power 3000. So previously capacitor reactance at f equal to 0 infinity. Now xc value will be infinity, will be decreased to 1000 when our frequency increases. That meaning is capacitor reactance will be decreases. Capacitor reactance decreases means output voltage will be decreases. Why output voltage will be decreases? Because you have taken output voltage across the capacitor. So across the capacitor means output voltage, capacitor reactance into current. That means reactance value will be changes means automatically output voltage also will be changes. So that's why you have to maintain whatever the current will be there. Reactance value changes, capacitor automatically voltage drop across the capacitor also will be changes. So capacitor voltage changes means output voltage also will be changes. That value will be decreases. Previously output voltage value equal to almost equal to input. Now output voltage will be decreases. Next one, third point important, very high frequencies. Let us example f equal to infinity. That is the example I am taking. F equal to infinity. Now what is the xc value? 1 by f into c, 2 pi f into c. In place of f I am putting infinity. So 1 by infinity value is 0. That means capacitor reactance value will be infinity or 0 here. Frequency is infinity. Frequency infinity means 1 by infinity. Answer is 0. X equal to 0. So capacitor reactance is 0 means capacitor act as a short circuit. So once it will be short circuit, capacitor act as a short circuit, then output voltage across the short circuit is 0. That means this circuit cannot be transmitted high frequency signals. Only transmit low frequency signals. Here important one is resistor is connected in series connection between input and output. Between input and output. So resistor is connected in the series connection, capacitor is shunt connection. This is called as low pass RC combination. So it will be allowing only low frequency signals. Capacitor is connected in the shunt connection or output voltage taken across the capacitor. Next come to the high pass RC circuit. So high pass RC circuit means it will be transmitting only high frequency signals and attenuates or stops the low frequency signals. That means previous circuit and this circuit, what is the difference? You observe this one. Previous one, input and output resistor is connected in the series combination, capacitor is connected in the shunt connection. Across the capacitor taken output in the low pass circuit. But here high pass circuit, capacitor is connected in the series connection between input and output. Across the resistor, you have taken output voltage. That means the resistor and capacitor interchange low pass and high pass circuits. Now, how we can say that this circuit act as a high pass RC circuit? That means high frequency signals will be transmitted without attenuation. That means high frequency signals unte matram vaatni amplitude em tagginchukunda input edaithe undo same input is transferred to the output. Whenever low frequency signals passing to this circuit, output value is 0. That means low frequency signals will not be appear in the output. That meaning is low frequency signals stop chestunni circuit. It will not enter into the output. Now how can say that? Again it will be 3 points. What are the 3 points? F equal to 0. That means frequency equal to 0 means a DC signal or constant voltage. Again capacitor reactance value for F equal to 0. So F equal to 0 means frequency 0 means 1 by 0. 1 by 0 means infinity. So once will be capacitor reactance will be infinity. Input and output connection in between capacitor is connected. Now capacitor will be open circuit or short circuit. Here will be open circuit. Because capacitor reactance infinity means open circuit. So once it will be open circuit, it means input and output will be no connection. So that's why input is not transmitted. For 0 frequency or low frequencies, capacitor reactance will be very high. Either it will be infinity or very high. So capacitor act as a open circuit. Input is not transferred to the output. That's why this circuit is called as blocking capacitor. So blocking capacitor means input and output in between they are connecting as a capacitor. For DC signal will be blocks. So previous already I studied in the capacitor blocks the DC signal, only allowing AC signals. Already I studied in the electrical circuits. And similarly, second point is frequency increase. What will happen? So frequency increase means F value increase. F value increase means one capacitor reactance value X equal to 1 by J into 2 pi FC. F value increase. So previous one F equal to 0. Now F value increase. That means 1 by denominator value increase. So denominator value increase means XC value will be decrease. So XC value decrease means reactance value some finite value. That means some voltage drop. Very small little amount of voltage drop across the capacitor. So remaining signal will be transmitted to the output. Now frequency increases further. F equal to infinity, third point. F equal to infinity, I am substituting X equation, capacitor reactance equation. 1 by 2 pi into, in place of F I am substituting infinity into C. C value is 1 micro or anything. 1 by infinity means 0. So capacitor reactance value 0 means capacitor act as a short circuit. So now input, whatever input will be there, now capacitor virtually act as a short circuit. So input is transmitted to the output for high frequency signals. So for high frequency signals, capacitor act as a short circuit. So that's why whatever input will be there, same input is transmitted to the output whenever frequency is high. That's why this circuit is called as high pass RC circuit. So up to now, any doubts will be there, you have to ask any student. I am explaining basic one, low pass or high pass circuit. So next one, important one, I am going to the sinusoidal signal applying to the low pass RC circuit. So low pass RC circuit means already you know that input and output in between resistor is series combination, output voltage taken across capacitor. This combination, shunt connection capacitor, this combination is nothing but RC low pass circuit. Low pass RC circuit. Now this circuit sinusoidal input you are applying. Then what is the output waveform? Already I told that sinusoidal signal applying to the linear network, output waveform also sinusoidal. That means input waveform, whatever the shape of the waveform, output also same shape, similar one. Except changes is only amplitude and phase angle. So that's why here I am not shown input and output waveforms of the sinusoidal signals. అంటే ఈ సర్క్యూట్ కి సైనసాయిడల్ సిగ్నల్ ఇన్పుట్ ఇచ్చాం, అవుట్పుట్ కూడా సైనసాయిడల్ ఇన్పుట్ ఉంటుంది, బట్ చేంజెస్ ఇస్ ఓన్లీ amplitude. So that's why that shape of the input and output waveforms is not shown, but here shown here is second diagram. You have to observe it, frequency response curve. What is meant by frequency response curve? So generally this will comes in the C amplifier experiment you have done in the EDC lab. C amplifier, x-axis will be frequency, y-axis you have taken is, you have taken as semi-log graph sheet, gain. So gain means 20 log V0 by Vi formula decibels you are using. That is nothing. Similar way, here will be frequency is x-axis, y-axis you are taken is voltage gain. So voltage gain means V0 by Vi. So that's why here it will be shown sinusoidal input waveform applying to linear circuit. Linear means low pass RC circuit. Output also sinusoidal waveform, but here will be shown frequency response curve. Frequency response curve means x-axis frequency, y-axis will be gain. Now this diagram is Laplace transform version. What is the meaning of Laplace transform version? So this Laplace transforms will comes in the signals and systems, I think 5th unit in your syllabus. May not be completed, but it will already complete in the control systems also. Control systems also, Laplace transform basics will become, mathematics also, mathematics subjects also, Laplace transform already I think you have studied a little bit. Here will be input voltage Vi of t, output voltage is V0 of t. Vi of t and output voltage is V0 of t. So current waveform is I of t. See the diagram here. So in place of Vi of t here shown is previous diagram, and this diagram you have to see. This is the previous diagram. This diagram, input voltage signal is Vi of t. Similarly, current value is I of t, and similarly output voltage value V0 of t in terms of time domain. But now see here this diagram, input voltage Vi of t applying Laplace transform, that means Vi of s. Similarly, I of t Laplace transform is I of s. Laplace transform means time domain to S domain conversion. That will comes in the signals and system subject. Already mathematics you have studied, very good. If not studied, no, don't bother about it. Signals and systems, again this Laplace transform will comes. And here will be important point is gain versus frequency curve. Input signal amplitude will fix. This is a very, very important one. Input signal voltage value amplitude is constant. So only variable is different frequencies. Simple example is in your function generator in the laboratory, input voltage magnitude is fixed one. Let us example 20 millivolts. This 20 millivolts will be constant, but varying frequency. That meaning is F equal to 1 kilohertz. Applying sinusoidal waveform. What is the output waveform? Similarly, input signal voltage value 20 millivolts. I am not changing, constant, but frequency I am changing 1 kilohertz to 10 kilohertz. Then what is the output voltage waveform? Similarly, input frequency F equal to 20 kilohertz. What is the output wave? Likewise, different frequency values, output voltage values you have to measure. Then you have to draw the graph. After this one, V naught by Vi. So V naught by Vi means voltage gain. Just 2 minutes. V naught by Vi. That means ratio of the output voltage by input voltage. So this is a low pass circuit, means low frequency signals will be transmitted without attenuation or low attenuation. The meaning is lower frequency signals ni takku attenuation చేస్తాయి. Higher frequency signals will be attenuated more. So for this diagram, we have shown the bandwidth. So how will we calculated bandwidth? So bandwidth is nothing but F2 minus F1. What is the F2 and what is the F1? F2 is upper cutoff frequency, F1 is lower cutoff frequency. Here lower cutoff frequency of the low pass filter is 0. Upper cutoff frequency is F2. So this F2 point how it will comes? ఈ F2 point అనేది ఎలా వచ్చింది? So gain value equal to 1 by root 2 times of the magnitude at particular frequency. Suppose F equal to F2 equal to 10 kilohertz. So 10 kilohertz point దగ్గర మనకి voltage gain maximum value లో 1 by root 2 times or 70.7% of maximum value. This point is called as upper 3 dB frequency. This is a very important one. So bandwidth is nothing but F2 minus F1. And next class we'll see. This is a low pass RC circuit diagram. What is the voltage gain calculation? So voltage gain means output voltage by input voltage. How it will be calculated, and find out the voltage gain magnitude and F2 value also. This will be seen the later next class. So thank you. Wait 1 minute. I will take attendance.
Sir,
Okay, but
please
thank-
stop